Find the value of tan inverse of 2 sine of 2 cos inverse root 3 upon 2. So we can write tan inverse of 2 sine of 2 cos inverse of root 3 by 2. Since we know that cos pi by 6 is equal to root 3 by 2. So we can write cos inverse root 3 by 2 is equal to pi by 6. So we can write 2 into pi by 6, which is equal to tan inverse of 2 sine of pi by 3. And we know sine pi by 3 value is root 3 by 2. So we can write here 2 gets cancelled. So tan inverse of root 3. And we know that tan pi by 3 is equal to root 3. So we can write tan inverse of root 3 is equal to pi by 3. So we can give the answer here pi by 3. So the value of tan inverse of 2 sine of 2 cos inverse root 3 by 2 is pi by 3. Is sine inverse of sine 5 pi by 3 is not equal to 5 pi by 3. Sine inverse of sine 5 pi by 3 is not equals to 5 pi by 3. Since the range of sine inverse function is minus pi by 2 to plus pi by 2. But here 5 pi by 3 value is not belonging to minus pi by 2 to plus pi by 2. And hence we can say that so sine inverse of sine 5 pi by 3 is not equal to 5 pi by 3. But this can be is equal to, let us simplify here, sine inverse of sine 5 pi by 3 is equal to sine inverse of sine 2 pi minus pi by 3 we can write, which is equal to sine inverse of minus sine pi by 3, which is equal to minus sine inverse of sine pi by 3, or we can also write it as sine inverse of sine of minus pi by 3. Since we know that sine of negative theta is equal to minus sine theta. So minus sine theta minus sine pi by 3 we can write sine of minus pi by 3. And since we know that the range of sine inverse x is minus pi by 2 to plus pi by 2. So minus pi by 3 is belonging to the range here. So we can write here sine inverse of sine minus pi by 3 is equal to minus pi by 3. So the value of sine inverse of sine 5 pi by 3 is equal to minus pi by 3, but it is not equal to 5 pi by 3. Okay. A kite is moving horizontally at a height of 151.5 meters. So we can say there is a kite at a height of 151.5 meters from the ground level. And if the speed of the kite is 10 meter per second, and when the kite is 250 meters away from the boy, the kite is 250 meters away from the boy. So let's take here 250 meters from the boy. There is a boy here whose height is 1.5 meters. The height of the boy is given 1.5 meters. So we can draw a line horizontal. It's a ground level. And you can see, let us mark this point as C. Then we have CK value is 151.5 minus 1.5, that is 150 meters. So it's a right angle triangle. You can see that BCK. Let us mention that BC is equal to X meters and BK is equal to the length of the string. It is also moving. So let me consider as a Y meters. We have the relation when Y is equal to 250 meters. So we have 250 square is equal to x square plus 150 square. That is x square is equal to 250 square minus 150 square. That is x square is equal to 250 plus 150 into 250 minus 150. So x square is equal to 400 into 100. That is x is equal to 20 into 10, which is 200. Means when the value of y is 250, the value of x can be taken as 200 meters. Okay, now also in generally we have y square is equal to x square plus 150 square. The height is constant given. So differentiating with respect to t, we have 2y dy by dt is equal to 2x dx by dt plus 0. Or this can also be written y dy by dt is equal to x dy by x dx by dt. So y dy by dt is equal to x upon y into dx by dt. And it is also mentioned that the speed of the kite moving horizontally is nothing but 10 meter per second. So we can write dy by dt is equal to, and x value is at x is equal to 200, y is equal to 250, you got x is equal to 200. So we can write x is equal to 200 divided by 250 into dx by dt is 10. So we can simplify and write here 25 here 8 times. So dy by dt is equal to 8 meter per second. Which means that we can say that how fast is the string being let out is, here y is denoting the string being let out, that is y. So we can say dy by dt is equal to 8 meter per second. So how fast is the string being let out is 8 meter per second. This is the answer. Water is leaking from a conical funnel at the rate of 5 centimeter cube per second. So let us consider conical funnel. And let us assume that the water level is say the radius PR and height is H. Let us assume that. So that volume of water in funnel, we can write volume of water in funnel V is equal to 1 by 3 pi r square H, where r is the radius and H is the height of the volume of water which is in conical shape. So differentiating, we have dv by dt is equal to, or before differentiating, first let us make the relation between r and h. And it is also given if the radius of the base of the funnel is, given 10 centimeter and the total height is given The total height is 20 centimeter. So here I can say this h 20 centimeter here. So let us mark these points as O, A, B, P, Q. Clearly we can say that the triangle O, A, B is similar to triangle O, P, Q. So that their sides are in proportion. R divided by 10 is equal to H upon 20. Or we can write R is equal to 10 upon 20 times of H. Or R is equal to 1 by 2 H. Okay. So we got the relation between R and H. So we can write volume V is equal to 1 by 3 into pi into R square, that is 1 by 4 H square into H. So V is equal to 1 by 12 pi H power 3. Now differentiating with respect to t. So we'll get dV by dt, which is 1 upon 12 or pi upon 12 into 3h square dH by dt. That is dV by dt is equal to pi by 4 h square dH by dt. Now our question is, it's given water is leaking at the rate of 5 centimeter cube per second, that is dV by dt is equal to, given dV by dt is equal to 5, and we need to find the rate at which the water level is dropping, that is dH by dt is equal to, we need to find when it is at the depth of 5 centimeter from the top. When it is 5 centimeter from the top, so we can say that the water level H is equal to 15. So 20 minus 15. So 5 centimeter from the top, which implies H is equal to 20 minus 5, which is 15. So when H is equal to 15 centimeters, and we need to find dH by dt when dV by dt is equal to 5. So let us substitute it here. So we have 5 is equal to pi by 4 into H square, that is 15 square, into dH by dt. And it is also given the, since it is decreasing, so we need to consider minus. Let's take minus here. So minus 5 is equal to, so which implies minus 5 divided by 15 into 15 into 4 into 1 by pi is equal to dH by dt. And further simplification, 5 here 3 times, and so we can write dH by dt is equal to minus 4 divided by 45 pi centimeter per second. So we can say that the rate at which the water level is dropping is minus 4 upon 45 pi centimeter per second is the answer. Okay. Prove that the function f of x is equal to 5 minus 3x plus 3x square minus x power 3 is decreasing on real numbers. We know the concept here. A function f is said to be increasing or decreasing depends upon f dash of x is greater than or equals to 0 or f dash of x less than or equals to 0. F dash of x greater than or equals to 0, we can say increasing, and f dash of x less than or equals to 0, we can say decreasing. So let us find its derivative. Derivative of the function f dash of x is equal to 0 minus 3 plus 6x minus 3x square, or we can write minus 3x square plus 6x minus 3, or minus 3 taken common, x square minus 2x plus 1, that is minus 3 times of x minus 1 whole square. And here x minus 1 whole square is always greater than or equals to 0 for any x belongs to R. So here we can say negative 3 times of x minus 1 whole square will be less than or equals to 0 for any x belongs to R. And hence we can say f dash of x is less than or equals to 0 for any x belongs to R, and hence we can say the function f is decreasing. Therefore, f of x is decreasing on real numbers. Find the maximum and minimum values of the function f of x is equal to negative of x plus 1 plus 3. And we know that mod x is greater than or equals to 0 for any x belongs to R, which also implies mod of x plus 1 is also greater than or equals to 0 for any real numbers. Then negative of x plus 1 is less than or equals to 0. Adding 3 on both the sides, 3 minus mod of x plus 1 is less than or equals to 3, or minus of mod x plus 1 plus 3 is less than or equals to 3. That is, the function f of x is less than or equals to 3. So we can say that the maximum value is, here the function is lies between minus infinity to, we can say, minus infinity to plus 3. So the minimum value cannot be defined. Minimum value of the function is cannot be determined, but maximum value is plus 3. So the maximum value of this function is 3 and the minimum value is not defined. Find the point of maximum of the function f of x is equal to sin x plus root 3 cos x in the interval 0 to pi. So to get the minimum or maximum value, we need to differentiate and equate to 0. So let's differentiate. F dash of x is equal to cos x minus root 3 sin x. For minimum or maximum value, f dash of x is equal to 0. So we can write cos x minus root 3 sin x is equal to 0, or root 3 sin x is equal to cos x, or tan x is equal to 1 by root 3. In the interval 0 to pi, we can give the value as x is equal to pi by 6, because tan pi by 6 value is 1 by root 3. And now, so in the interval 0 to pi, the closed interval, so we may consider the values as x is equal to 0, pi by 6 and pi. Let us check at these values. F of 0 is equal to sin 0 plus root 3 into cos 0, that is 0 plus root 3 into 1, which is equal to root 3, and f of pi by 6 is equal to sin pi by 6 plus root 3 cos pi by 6, that is 1 by 2 plus root 3 into root 3 by 2, which is 1 plus 3, 4 by 2, that is 2, and f of pi is equal to sin pi plus root 3 into cos pi. Sin pi value is 0 plus root 3 into cos pi value is minus 1, so minus root 3. So here we can observe that among these three, the maximum value obtained is 2 at x is equal to pi by 4. So we can conclude that at x is equal to pi by 6, the maximum value is equal to, maximum value of the function f is 2. So we can conclude the point of maximum is nothing but the point is x is equal to pi by 6. So this is the point, at this point the maximum value gives, that is 2. So pi by 6 is the answer.